Welcome to a new test and teardown video. Yeah, if the acoustic is a little bit different, that is because we are definitely another location. And that is because this oscilloscope, I just can't have it into my lab because it's just way too big. I think this is a new record for oscilloscope sizes. So this is a DISA Copenhagen Universal Indicator 51B00. It is a dual beam precision oscilloscope, and it's from DC to 500 kilohertz. Oh, yeah. And it is about from 1965, 46 tubes, and the weight is 46.3 kilos. The width is 42 centimeters, height 45 centimeters, and it's 62 centimeters deep. Yeah, this table here is actually a 6-chair table. But in this picture here, it looks quite small, but that is just because this scope is huge. I haven't yet figured out exactly what is going on with the two vertical inputs, because you see, we got some inputs right here for two different inputs, so you can select and compare two inputs into this channel. We got gain, of course, and volts per division and all those kind of things. But up here, look at that. It looks like we got a little oscillator for whatever reason. And it's the same over here. The same oscillator, the same tuning, this and that. Exactly the same input. And here comes the real fun things. Oh, we got some shadows. Intensity common. Focus left. Intensity left, right. And focus right. And also, look at this down here, horizontal input left channel and horizontal input right channel. So in XY mode, we have actually 4 inputs, I would suggest. I don't know. So it is a true dual channel. We got a nice little plastic grid here. This looks a little bit weird with the holes right there, and we got some other holes up there with some bulbs. I guess we are missing some sort of a outer plastic or metal kind of thing. Yeah, we got the normal sweep, mark and calibrating generator. We got some markings we can put in. It is an amazing oscilloscope with tons of really funny features. But we should definitely open and inspect. We cannot just power it up. On the back there's not so much to see. I guess that will be a fan of some sort. And that will be mains input 3 amp fused. And the little old power entry. And here is my serial number 363. To get the chassis away is very difficult, simply because of the weight. But the vertical amplifiers, they are plug-in modules, and they are also really big. So maybe I can reduce the weight a little bit by taking those out. So here's... Yeah, okay, they're actually quite heavy. So let's see. We probably got all the transformers and all the good heavy stuff there at the back. And look at that, horizontal is also a really big plug-in module. I think I need 2 hands to pull this thingy out, but that will definitely help me. If I'm still breathing a little bit weird, it is of course because I'm old and fat and all that, but It's also because this thing is definitely big and heavy. Holy mother of all oscilloscopes. And look at that transformer. How about that, big baby? Nice cable for everything here. A beautiful job with the cables for the plug-in here. Oh, that is nice. Oh, we got another no. What's in here? I can't wait to count if all the tubes, if it's really right, we got 46 of them. That's of course all the regulated power supplies, right? And another transformer, yeah, that will be a filter choke. Tons of capacitors. Oh, that goes good. So the bottom of the unit, now we can see the bottom of the CRT. We got some, this can't be high voltage entry, can this? It's not that well protected. And that will be all the connections to the main transformer. Look at all those connections. We got capacitors here and capacitors, tons of capacitors. The main switch is just huge. I think the CRT is really special. Look in here, the deflection system. I don't know how can I get light in there and focus in there at the same time is absolutely impossible. But there is something. I wanted to get back to this deflection issue here with this piece. Meanwhile, I figured this out. This is a connector that interfaces to the pins in the glass, and I don't know if it's easy to see, but yes, from this angle, look at that, you can see the pins through the glass that goes outside of the side of the glass, and this interfaces to this piece of brown part. So that is the connection, and that means the two wires right here is the green and gray, and green and gray again, and we got two more sets of that here to the right here and down there. So that will be the 4 deflection cables that goes to either the amplifier side or the horizontal side. So that is how you access this, and that means all we have here, that will be of course, cathode, focus, brightness, and yeah, all the different stuff. And since this is a true dual deflection and dual cannon, dual everything CRT, that is why we have all those extra brightness and focuses, and everything is individual for each of the two systems. So inside my vertical amplifiers and oscillators, I put one up and one down so we can see both sides at the same time. Isn't that smart? So look at that, with the inductors and capacitors here. So all this creates the oscillator. So all this is probably for generating some signals to stimulate some sort of test system, and then the result goes in here, and then you can display this. It's quite funny. So it's not just an oscilloscope, but more like a complete test unit that also generates the signals. And that is a little bit interesting. I think we will find 9 tubes in this unit. They are a little bit hidden. So we need to be a little bit smart to figure out all this. And potentiometers here and switches. You need to push this one to make it connect. And then we have the variable gain for all that input. Yeah, let's look a little bit at the tube. See, we got 1, 2, and 3 in this unit because there is one right there. See? So that will be 3 in this unit, okay? 4, 5, 6, 7, 8, 9. There you have it. So the horizontal plug-in is probably the most complicated tube-based horizontal I have seen in a long time. And obviously it's also full of a lot of tubes. I haven't even counted them yet. And oh yeah, let's again look a little bit at the features. It's really wild what we got here. So we got analog input for horizontal, or you can of course turn this on or off, right? Or internal, I guess. Then you go into the sweep system. So we got something going on here with time division, and we got multiplier for that, I guess. Here we got the trigger system, stability times 1, internal left right, trigger level mode. And here is of course the analog input for the left channel in case you want to use this one. And yes, again, we can turn it off or internal. And down here is a mark and calibration generator. And it is, I think we've got 2 different systems here. We also got the intensity modulation input. So we can use this to modulate left, right or left. And then internal generator. I think that will be the intensity is now controlled by this system, I guess, right? And we got trigger input. We got another marking input. And this marking input, of course, goes to some amplitude adjustments, and you can put this marking input somewhere. So this adds something so you can have a pulse. You know what is the pulse, and then you modulate your input signal with that. So you have a very accurate timing pulses. Of course, back in the days, all those milliseconds and microseconds and stuff like that's just free running stuff with capacitors and resistors and stuff. Maybe not that accurate, so it's a good idea to have it like that. And yeah, pretty funny. And again, tons of capacitors for very high voltages, and I haven't yet found any leaked or broken capacitors, especially these sizes, and also stuff like this. I look for leaks or burns, and also in the resistors you can find burnt parts, but it's looking really good. Some tubes, they point up, and you see the sockets down there, they point down, and that is of course to create isolation, because the outer part in many of those tubes, that will be anode, so it's a sensitive part of the tube. And instead of having the need of putting those isolation metal tops on, and you can see those sockets here, they actually support the isolation tops, but also this will make the tube run much hotter. So you don't want to use them really if you can avoid it. And down here we can also see some tubes here in the middle, and out here we can see some more tube sockets. Yeah, let's try and flip this. And that is the bottom view of the horizontal. And again, the build quality really remind me of 1960s HP or Tektronix, some of the big American brands that really made high priced, super top quality products. You can see here it's the same build quality. Also the round parts and the way that everything is mounted, this looks like Tektronix plugins, and even the connectors here at the back looks a lot like Tektronix plugins. Also those screws that mount everything, this is also exactly what you'll see. Yeah, it's really, really nice and clean. Another real fun thing to try and check out with old stuff like this, and that is the fuse. So this is a 3 amp, and this I believe is the old original 3 amp fuse, and it's nice and intact and not corroded in any way. So this tells me there's a high chance this unit could work. I mean, if you find a broken fuse or a new modern fuse, this tells me it was previously blown and replaced, and then oops, maybe there could be a problem I need to fix. So that is good news. Just to recap what I said earlier about the plugins being a little bit similar to Tektronix. This one is definitely a Tektronix plugin, but look at that. The way that everything here is built is more or less the same. However, the locking mechanism in many of the older Tektronix is very, very complicated. See, there's a moving part, a little spring and all sorts of stuff. So you need to lock this, and then you turn this, and then it moves the little thingy in here and out. So this is a much more complicated way to do it. But here, the Danish guys, they just figured out, hey, if you just have a long threaded rod like that, then it's easier, isn't it? Much, much more simple. And the build quality is definitely the same. And again, see, the connector here at the back is also the same way they did it. More or less also the same type of connector. Look what I just find. So around this yellow capacitor, look at the metal here. See, all the way around this one. I bet that will be either something dropped into this unit. You can even see here it dissolved the text down there. How is that even possible? So that means it's some sort of acid. I'll take a little sample of this and see what it is. Here I took a little sample right there. Just clean water and put it on a cotton bud. And here's the fun thing. When I try to measure, let's see if I can do this with only one hand. If I try to measure, I get negative resistance, and that means it's actually generating a voltage. And so you're kind of getting what I'm talking about. See? And that is because of the chemicals here is from the capacitor. Oh dear. Inside this extra little shield box we got right here is of course the high voltage. And look at that. It's a high voltage rectifier tube, and we got 3 of them. Let's go over here. 2 more. And that will be the oscillator and feedback system. Yes, so it is a regulated high voltage, and it's plus minus 1700 volts for the tube. And there's another, I think it is 18 or 1900 volts, and that is for the intensity. That one needs a little bit more negative. This way it can turn the intensity correctly on and off. And that will be, of course, the different feedback voltage measurement resistors. Yeah, a beautiful power supply with all the windings and good stuff right here. So here is my first power up. I'll just try the power supply without any kind of plugins and put everything here in the middle, and then let's see how that one goes. Maybe the on-off switch at the back could be turned off. No, it is on. So this is already, what is that, 20 volts, and it's using 3 watts. So we can easily just crank this up. And then we will get a little bit of heat in the different tubes. Now fan is starting to rotate. This is 100 volts and it's using 3640 watts. So just continue. 120 volts. It's using 70 watts. I don't see any kind of light whatsoever. 180 volts and it's using 100 and... Oi, so that was illumination. Oh, look at that, we got beam. So that is focus. Here is, see, we got the 2 different focus. So one focus is super duper good. And the left one right here. Oh, look at that. Oi, oi, oi. So it's still warming up the different voltages and all those kinds of things. And it's getting really nice and bright, and it's almost white. So this is 100 watts at about 180 input. So yeah, I feel I want to power up some more. Oy, oy, oy. Maybe I should measure the voltages and they are regulated and all that kind of stuff. But I mean, we got a beam and we got light and we didn't get any smoke or explosions. So I would definitely call this a good first power up. So let's try and see what happens. I think I put in 2 small fuses for my vario here. So I think they're just gonna blow. But let's just see what happens, okay? It's using 600 watts, 400, 350, and it's probably going to use a lot more once it gets warm. So this is 350, 400. It's using a lot of power, huh? And we got, what have we got here? I have a finger on the where is everything? It has something to do with the, yeah, here we go. Triggering. Here we go. Oh. Dear, this is nice. And here, yes, look at that. Oh, there's super long glow in this. This is sexy. What do you think about that? Let's put in some input. Well, I definitely need to go and find a bigger vario. So this is 385 watts. Oh my goodness. I can turn it off immediately. So I wanted to use the amplifier outputs as inputs. Let's see if that is possible. If this oscillator is doing anything. No. We got some tuning gain here. So we don't seem to be having any kind of luck with that. Let's try over here. Now, I need an external signal. Probably this oscillator stuff is not working. So this is an external signal, 1 kilohertz, 4 volts peak. And here we go. Of course, needs to poke around with the and how do we figure out this trigger thingy? Here we go. Oh, this is beautiful. We got a nice picture. Look at that. Intensity changes. But how is this trigger? Internal left, right. Oops. There's definitely something I need to learn how to figure out here. Yeah, we got a little bit of ripple probably. But it seems to be working. Only 270 watts. So look at that, huh? This annoying potentiometer here is completely defect. I can't get the damn picture in the middle. I want to say thank you very much for watching. It was a pleasure playing with this big one.